Hello everyone, I am Theresa Cherian, Research Scholar, Karunya Institute of Technology and Sciences, Coimbatore. Here is my paper title, Experimental Comparative Analysis on Convolutional Neural Network and Recurrent Neural Network on Aspect Level Sentiment Analysis. So here is my overview of the presentation. What is sentiment analysis, then types of sentiment analysis, how the process is done in sentiment analysis, and I've selected two networks, network architectures, convolutional neural network and recurrent neural network in sentiment analysis application. So here I am starting with the introduction of NLP. Natural language processing aims at providing computers or machines with human-like features to understand text and words using artificial intelligence tools. So here are different tasks of NLP which are given: speech recognition, tagging, data analysis, reference resolutions, and language generation, etc. There are various ways to analyze the data in NLP. So these are topic analysis, time series analysis, sequence analysis, then network analysis. So topic analysis is basically organizes and understands the collected data based on a text data by assigning tags or categories according to each text topic or theme. Then in time series analysis, it's a statistical method to analyze the past data within a given time, within a duration of time to forecast the future. So it comprises an ordered sequence of data at an equally spaced interval. Then in sentiment analysis, it refers to the use of NLP, text analysis, computational linguistics, and biometrics to systematically identify, extract, quantify, and study affective states and subjective informations. Then last case is network analysis. Here in this analysis is performed using different network algorithms such as Bayesian networks, neural networks, and RBF networks, etc. So here is the introduction about sentiment analysis. It's a method to retrieve useful insights from a large collection of unorganized or unstructured data. Different steps involved in sentiment analysis are data collection, data pre-processing, sentiment classification, output preparation, etc. Then in data collection, a large collection of data is collected or fetched from the blogs, websites, social media, etc. Then that collected data will be pre-processed in the second step, in data pre-processing step. So there all the stop words, punctuation, and special characters, that means all the irrelevant data or characters, will be removed from the extracted data. Then sentiment classification, a subjective expression, are processed using suitable machine learning algorithms to classify the sentiments such as positive or negative sentiments. Then the last one is the output preparation. While preparing the output, different applied algorithms are evaluated and prone for better performance. So the output will be visualized in the form of a graph or charts using different data visualization tools. So here is the diagrammatic representation of data pre-processing. So after data pre-processing, vectorization is the second method. So during vectorization, it's a process of converting text into real numbers is called vectorization. Various methods used are bag of words, term frequency, inverse document frequency, and Google word to vector. So these are the available methods for vectorization. In this study, we have used TF-IDF vectorization. That means term frequency, inverse document frequency vectorization. And after that, training the model, testing the model, and using different deep learning models, we are performing all these processes. And here is a type of sentiment analysis. So there are basically three types. document-based, sentence-based, and aspect-based. In document-based sentence analysis, the whole document is considered for analysis, and the document as a whole is classified as positive or negative sentiments. In sentence-based analysis, every sentence is extracted and analyzed to classify the sentiments as positive and negative. And these two, document and sentence-based analysis, are not giving an expected accuracy. So the third one is aspect-based sentiment analysis is more effective. Here is an example in this cases, such as the sentences gives two aspects in a single statement. So the salmon is tasty while the waiter is very rude. So here about the food and about the service, there are two aspects given. There is a positive aspect about the food and the negative aspect about the service. So such a cases, the aspect-based sentiment analysis is more effective. So all these information steps of CNN-based sentiment analysis, which we have already discussed in the previous slides. In the data pre-processing states, all the symbols, digit, punctuations, everything is removed to improve the efficiency and performance. And lemmatization is a process of capturing the context of a word or converting it into its base form. So vectorization is already discussed. In vectorization, all the text is converted into real numbers. And this is an example of convolutional neural network model. And RNN, the analysis based on RNN is a deep learning model that evaluates time series data. The speciality of RNN networks are it holds memory for storing previous outputs, and present computation depends on the stored previous outputs. So the previous output will be the input of the next phase. So all the pre-processing steps are similar to CNN networks. So here is an example of recurrent neural network model. Then coming to the point of accuracy performance matrices. So accuracy is the performance metrics that we are considering in this study. So accuracy is the ratio between the number of correctly classified instances to that of a total number of instances. Here is the equation which is used for calculating the accuracy. TP plus TN divided by TP plus FP plus FN plus TN. So these are the terminologies associated with the metric. Our true positives are the cases when actual true cases are correctly predicted as true. And true negatives are the cases when actual false cases are correctly predicted as false. Then false positives are cases when actual false cases are wrongly predicted as false. Then false negatives are cases when actual cases are wrongly predicted as false. Then next point is data sets used for this study. There are two data sets used here, US airline and presidential debate data set. So here is the review count and sentiment count of the first data set. Here we can see that there is an airline review count. On the x-axis there are different airlines mentioned, and the count, the number of passengers which those who are given the comment are on the vertical axis. So here count and sentiment neutral. There are three sentiments are given: neutral, positive and negative. So here we can see around 3,000 passengers are given neutral comments. Around less than 3,000 passengers are given positive comments. Then there are more passengers are given the negative comments. So here is the count and sentiment count of second data set, which is presidential debate data set. Here is the topics which are discussed in the debate, and here is the comments on sentiments on each topic. So this is a representation of accuracy and loss of CNN on US airline dataset. So here accuracy and loss graphs are given. So while giving the accuracy, it's around 75% in the case of CNN, and the loss elevates up to 0.7. So that means the loss is less here. Accuracy is 75%. And this is on the same data set. The accuracy and loss are calculated based on RNN. So here we can see that around 78% of accuracy based on RNN and 0.87 of loss, which are represented in the graph. So as mentioned, here is the accuracy of 75% in the case of CNN. Accuracy is 75 and loss is 0.7. And in the case of RNN, accuracy is around 78% and loss function is 0.87. So here is the accuracy and loss of CNN on presidential debate data set. So here we can see that its accuracy is around 65% and loss is comparatively high. And in the case of RNN also, loss is comparatively high and accuracy is around 65%. So here is the tabular representation of all the performance matrices which we have studied. RNN and CNN, based on the accuracy and loss, we have calculated the performance. So CNN gives 79.64% of performance and RNN gives 74.27. So here on the second data set, CNN gives more performance and RNN gives comparatively less. So from our study, comparative analysis on RNN and CNN, we have concluded that CNN gives comparatively better performance than RNN, but still these two loss values are not satisfiable in the case of RNN and CNN. So there are future research directions which are proposed to improve the performance. So a hybrid CNN and RNN architecture can be proposed, and from the above comparative analysis, we have concluded that the accuracy and loss function is not appreciably good for analysis. So the combination of CNN and RNN can be proposed, and attention mechanisms to capture spatial and temporal parameters can be incorporated to improve the accuracy and reduce the loss of the analysis. Then effective deeper neural architecture with more epochs can be implemented. That means while we are doing the training and validating the data, number of epochs can be increased. Then weight is another point of consideration. Weights have to be regularized. So these are the future directions that we can propose. In the future, this paper will be enhanced with the novel deep neural network model for aspect level sentiment analysis. So here I am concluding. This paper performs an experimental analysis on sentiment analysis using two architecture, network CNN and RNN network architecture on two databases. On two data sets, US airline and presidential debate databases. So the experimental results prove that CNN architecture provides a better score compared to RNN. However, to improve the accuracy of the analysis, future research directions are also discussed in this paper. So these are the references which I have referred to study about these two analyses. Thank you all.